السلام عليكم ورحمة الله وبركاته. Miro Nasroor, chemistry teacher. Our topic today, reaction of alkenes. Alkenes. Alkenes known as olefins. They are organic compounds that consist of carbon and hydrogen atom with one or more carbon-carbon double bonds in their chemical structure. The general formula for the alkenes is CnH2n, where n is the number of carbon atom in the molecule. Alkenes are hydrocarbons because they are made only carbon and hydrogen atoms. Alkenes are unsaturated because they have one or more double bond in their chemical structure. The first member in the alkenes is ethylene, ethene. Preparation of ethene in laboratory. Ethene prepared by dehydration or removing water from ethyl alcohol or ethanol. When ethanol is heated with excess of concentrated sulfuric acid at 180 degrees Celsius. Preparation of ethene in laboratory. The flask that contains ethanol and sulfuric acid, heated up to 180 degrees Celsius. When the ethene gas is evolves, it passes through sodium hydroxide to remove the fumes of sulfuric acid and collected by down displacement of water because it is a non-polar and non-dissolve in water. The reaction takes place by two steps. The first step, sulfuric acid reacts with ethanol to form ethyl hydrogen sulfate, CH3 CH2OH plus H2SO4 at 180 degrees Celsius give CH3 CH2OHSO3 plus H2O. In the second step, the ethyl hydrogen sulfate decomposed to give ethene and sulfuric acid. CH3 CH2OHSO3 give CH2 plus H2SO4. By adding the two equations to get the net equation CH3 CH2OH by using concentrated sulfuric acid at 180 degrees Celsius give CH2 plus H2O. Physical properties of alkene. The physical state. The first three members are gases. The next 14 members are liquids. The remaining alkene are solids. Gaseous alkene, alkenes which contain 2 to 4 carbon atoms. Liquid alkenes, alkenes which contain 5 to 15 carbon atoms. Solid alkenes, alkenes which contains more than 15 carbon atoms. Solubility. The alkenes are insoluble in water due to their nonpolar characteristics. The alkenes are completely soluble in nonpolar solvent such as benzene, ether, carbon tetrachloride. The melting and boiling points. By increasing the number of carbon atoms in the alkenes, the intermolecular force increase and the boiling points and melting points increase. Polarity. Alkenes are weakly polar. The polarity depends on the functional group attached to the compounds and the chemical structure. Chemical properties of alkenes. Number 1. Combustion reaction. Alkenes burn with oxygen as exothermic reaction at higher temperature and convert into carbon dioxide and water. As example, C2H4 plus 3O2 give 2CO2 plus 2H2O and energy. Addition reaction. Alkenes enter addition reaction to form saturated compounds because pi bond is easily broken and new sigma bonds are formed to the atom being added. Hydrogenation of alkenes is the reaction of addition of hydrogen to the CC double bond of alkene in presence of catalyst to form corresponding saturated alkane. As example, CH2 CH3 plus H2 give CH3 CH2 CH3. Hydrogenation reaction in which two hydrogen atoms are added across the double bond of alkene resulting in saturated alkane. Take place by addition of a catalyst divided nickel or platinum. Hydrogenation reaction is a thermodynamically favorable reaction because it forms a more stable product, exothermic reaction, in which 1 mole of hydrogen molecule break 1 mole of pi bond in alkene to form a saturated alkane. In this equation, there is only one double bond, so we need only 1 mole of hydrogen molecules. In the second equation, we have 2 double bonds. We need 2 mole of hydrogen molecule to break these bonds. Halogenation reaction. The alkene halogenation reaction, which dihalides, specifically Cl2 or Br2, is added to a molecule after breaking the carbon-carbon double bond. Halogenation reaction to detect alkenes. When a gaseous alkene like ethene passes through pure liquid bromine dissolved in a tetrachloromethane, the reddish brown color of bromine is disappear as it reacts with the alkene. Ethene reacts with bromine to make an addition reaction to give 1,2-dibromomethane. CH2 plus Br2 give CH2Br, CH2Br. When ethene added to bromine, the reddish brown of bromine is disappear because of the formation of 1,2-dibromomethane. At room temperature, alkene change the reddish brown color of bromine to colorless, but alkane don't change the reddish brown color of bromine. Hexane don't change the reddish brown of bromine. Hexa1ene change the reddish brown to colorless. Note: alkane and bromine react by addition at room temperature, but alkane and bromine react by addition need large energy from ultraviolet rays, so this reaction doesn't occur at room temperature. Hydrogen halide reaction. All alkenes react with gaseous hydrogen halide at room temperature. The double bond break and the hydrogen atom join to one carbon atom of the double bond, and the halogen atom joined to the other carbon atom to form alkyl halide. The reaction product between alkenes and the hydrogen halide depend on the type of alkene. There are two types of alkenes. Number 1, the symmetrical alkenes. It is the alkene in which the two carbon atoms which are attached to the double bond carry the same number of hydrogen atoms. The asymmetric alkene, it is the alkene in which two carbon atoms which are attached to the double bond carry different number of hydrogen atoms. The symmetrical alkene, it is the alkene in which the two carbon atoms which are attached to the double bond carry the same number of hydrogen atoms as ethene. Ethene contains one double bond between two carbon atoms, each one connected with two hydrogen atoms. Hydrogen halide reaction with the symmetrical alkene. The reaction between ethene and hydrogen chloride give chloroethene. In this reaction, the double bond will be break and hydrogen attached with one carbon atom and chlorine attached with the other carbon atom to form chloromethane. The asymmetrical alkene, it is the alkene in which the two carbon atoms which are attached to double bond carry different number of hydrogen atom. Hydrogen halide reaction with the asymmetric alkene as 1-butane produces 1-bromobutane or 2-bromobutane. 1-bromobutane, 2-bromobutane. Markovnikov's rule. When adding an asymmetrical reagent XH to an asymmetric alkene, the positive part of the reagent hydrogen is added to the carbon atom which carries the largest number of hydrogen atoms, and the negative part of the reagent is added to the carbon atom which carries the least number of hydrogen atoms. When adding hydrogen chloride to this molecule, this carbon atom is connected with one hydrogen atom, but the other don't connect with hydrogen atom. So the chlorine negative ion will connect with this carbon atom, and the hydrogen ion will connect with this carbon atom. In the other molecule, the hydrogen bromide is added, so the bromine negative ion will connect to the carbon that has the least number of hydrogen atom. This is carbon atom, and the hydrogen and positive ion will connect with the carbon that contains the larger number of hydrogen, so it will connect with this atom. The reaction between propene and hydrogen bromide give 2 bromopropane, but 1 bromopropane not formed. When adding hydrogen bromide to the double bond, the hydrogen is connected to the carbon that contains the large number of hydrogen, so it connects to this carbon atom, and bromine will connect to the carbon atom that has the less number of hydrogen atom, so it will connect to this carbon atom and no exchange, so the result will be 1 bromopropane. Catalytic hydration reaction. It is the addition of water to alkene in the presence of a catalyst to produce the corresponding alcohol. Recall that water is a weak electrolyte. Its ionization gives small concentration of hydrogen ion. So sulfuric acid must be used as a catalyst to increase the concentration of hydrogen ion to break the pi bond between the two carbon atoms. The reaction between ethane and water gives ethanol. CH2 CH2 plus H2O give CH3 CH2OH. Change ethane to ethanol in presence of concentrated sulfuric acid at 80 degrees Celsius. Step number 2. Ethyl hydrogen sulfate is hydrolyzed to regenerate sulfuric acid and ethanol. In this equation, the hydrogen ion will connect to the bisulfate ion to form sulfuric acid, and the OH negative ion will connect to the CH3CH2 to form ethanol at a temperature 110 degrees Celsius. The net equation will be CH2 plus H2O give the CH3CH2OH in presence of concentrated sulfuric acid at a temperature 110 degrees Celsius. Oxidation reaction. Alkenes are oxidized by oxidizing agent as hydrogen peroxide H2O2, the alkaline potassium permanganate solution KMnO4. Oxidation reaction. Beer's reaction. The reaction of alkenes with potassium permanganate solution KMnO4 in alkaline medium to detect the presence of double bond by discharging or disappearance of the purple color of potassium permanganate, forming dihydroxy compounds called glycols. When ethene gas passing in alkaline potassium permanganate at room temperature, the purple color of the potassium permanganate disappear and the ethylene glycol is formed. CH2 plus H2O plus oxygen resulted from the oxidizing agent by use of KMnO4 alkaline medium. It gives CH2OH ethylene glycol. The ethylene glycol, ethene 1,2-diol, is an organic compound with the formula CH2OH-2. It is mainly used for the two purposes: 1. A raw material in the manufacturing of polyester fibers. 2. Antifreeze substance. The ethylene glycol is used as antifreeze substances used in car radiators because ethylene glycol has two polar OH groups which can form hydrogen bonds with water molecules to prevent their combination together to form ice. The hydrogen bond resulted between ethylene glycol and water molecules. Reference at the end. Thank you and goodbye.